Just doing a quick sound check, guys, and then we should be good to go. All right, folks. So this is something that I know I've been wanting to do for a while, but I just haven't had the time. And to be honest, I'm also running out of questions as well. Like most of the time, I'm actually sitting there creating questions, but at the moment, I just don't have enough time to go through the questions. So yeah, so what I'll do is I'll actually go through each one of these questions, starting off with yeah, like from question 1 all the way to the end. What you need to do for achieve merit and excellence as well. What I'm going to be doing is kind of working, how do I say this? So I'm going to be recording at the same time as live streaming. This is, I know I tried this a couple of weeks ago with the 2020 paper. So pretty much going to be doing the same thing here. So if you do need to kind of like just have a question or anything like that, just start throwing questions straight away on the chat. I'm happy to kind of like pause and yeah, kind of like talk you guys through the question. What I will do though is like when I'm actually explaining the question, I'm going to record, so I probably won't answer your guys' questions. But then once I stop the recording while streaming, I'll just open up the floor for some questions as well. Yeah, I'm all right. Just trying to maintain my voice level at the moment because I've been doing tutorials every night and it's just been bit, how do I say it? Getting a bit croaky, if that's the word to choose. Okay, so let's just gonna get a few more things ready and then we'll probably get started at about 8:03 and then we'll be on our way. Lovely. Of course it has to get stuck, eh? No, it's good to go. Nice. Where are you guys coming from today? Which part of New Zealand? Auckland? Hamilton. Nice. Nice to be out and about. Christchurch. Sweet. Huntley. Timaru. Nice. Okay, guys, look, let's get going because I know that I'm gonna kind of like power through these questions. So must click record. Cool. So we're up to the first question here. With the first question, what we've been given is u and v is this. Find u dash, no, u conjugate minus 3v. What I'm going to give you guys is like, I'm going to give you guys like a couple of minutes to kind of like have a go by yourself. And then I'll actually go through the answers. All right. So if you guys want to have a go at this, I'll give you guys like just under a couple of minutes and then I'll go through the answers. Nice, nice. Welcome. Palmy. That is a wide variety of folks coming on. That's pretty cool. Thank you for joining us today, folks. Really appreciate it. All right, guys, I'm hoping that you guys have had a chance to have a crack at this question. I'll slowly start working through this at the moment. So I guess our first step is to have a look at the conjugate of u. Because u is equal to 2 plus 3i, we're just going to have to rewrite the conjugate of u as 2 minus 3i. And we've got 3v, so that's pretty much straightforward. So we've got u conjugate minus 3v, so that's going to be 2 minus 3i minus 3 multiplied by v, which happens to be 1 minus 4i. So expanding the brackets, so we've got negative 3 times 1 and negative 3 times negative 4i. So what do we got? Negative 3 and plus 12i. And this simplifies to negative 1 plus 9i. Nice way to start the paper, especially in 2017. You get an achieved for this question. Nicholas, you can send it, mate. But like I said to you, like I'll probably get to it somewhat later this week because work is yeah, schoolwork is trying to get on top of me a little bit as well. Are you guys okay with this question? Can we move on to the next question? Just let us know. Kind of forgot what question. I think I did say move on. Okay, cool. Let's go to question 1b. So with 1b, what you got is basically, yeah, rationalizing the denominator and have a go at this question. So again, I'll give you guys about 90 seconds for this, all right? Because these achieved questions, like you really don't want to be spending like too much time on them. One of the strategies that I say to folks is like, you really want to be spending a good chunk of time on your merit and excellence questions. And if you find that an achieved question is taking you more than 4 to 5 minutes, then I'd almost say just let it go. Don't bother with that question and just move on. Come back to it later. Because like sometimes you can spend like 5 minutes on an achieved question, and then you go to the merit question and you realize you did that merit question in like 1 minute and you get 5 points. All right. So just there's a little bit of tips here and there. So if you find that you're taking too long to do an achieved question, just skip it and then try and come back to it at a later time. Real gamer, yeah, that's I know it's kind of like so easy to do that plus C thing, right? Like some people forget it, some people like, oh yeah, need to put that in differentiation. So anyway, I'll go through this question now. I'll go at a fairly slow pace, guys. So if you are still doing this question, hopefully I'll catch up to you by the time you finish your question. Cool. So what we want to be doing is for this question, we want to be rationalizing the denominator. What do I mean by that? That means in the denominator, I no longer want to see the square root of 7. So that means I've got to multiply it by the conjugate of it, which is going to be 5 plus root 7. And in the numerator, I'm going to get 5 plus root 7 as well. So with that in mind, I've got to multiply the 36 with 5, 36 with root 7. So that's going to give me 180 plus 36 root 7. And as for the denominator, you've got difference of 2 squares. Now you can actually do this in one step. And I know like when I teach my guys is that like I kind of say to them like, look, you don't even need to worry about the inside term because you're doing difference of 2 squares. Because remember, this is like a minus b times a plus b. So this is a squared minus b squared. And pretty much that's what's happening here. So we've got 5 squared. Minus and plus makes minus. Square root of 7 times square root of 7 is just 7 by itself. So with that in mind, our numerator then is going to be 180 plus 36 root 7 divided by 25 take away 7. So 25 take away 7 is 18. And of course, we need to split this up because If you look at the question's actually asking an a plus b root 7. And right now we've got an 18 in the denominator. So we're going to split this up as 180 over 18 plus 36 root 7 over 18, which means we are going to get 10 plus 2 root 7. And of course, the grade for this is achieved. So you do need to get to this part right here because that actually matches the a plus b root 7 form that they're asking for at the start of the question. Yeah, so that's basically an achieved for this question here. Okay. Love that, Simon. Good little crack up. DLR, I think I need to talk to you a little bit more in detail about the context of your question. So when we do level 1 TEG, pop down and remind me again, mate. Ivan, we're going to do a question like that today. So I think it's one of the questions that come later on in the excellence questions. And trust me, like it's not that difficult, man. Like you'll get it in no time. Um, you've pretty much got everything there you need. And I'll show you how to do that later on today. There we go, Ivan. Yoke's got your help there. Cool, guys. Are we ready to go on to the next question? Because both of these are achieved questions. Again, like I said to you guys, if you're spending like 5 minutes on these, then you gotta move on because it's like um, you can get delayed with attempting those merit questions and so on. So yeah, moving on then. Okay, so next we go to question C, which is a merit question. Like calculus papers, surprisingly, they've been doing this nice format of like 2 achieved questions, 2 merit questions, and an excellence. So with that in mind, like this is a merit question right here. And what we need to do is, what are we doing? We're writing x in terms of p. And our first step is like, we've got to figure out how to get rid of that square root symbol. A lot of people tend to do this straight away. And in this case, it's not really going to help because you've got 0 on the other side. So we want to rearrange it first. So we want to rearrange this as p square root of x minus 2 equals 5 root x. Once we do that, now we can actually square both sides. So when we square both sides, p squared is just p squared, and then square root disappears, which means we've got x minus 2 left here. And then 5 squared is 25, and then square root of x is just x. Our next step is, of course, expanding the brackets because we are trying to write x in terms of p. So we want to have x by itself. So we've got p squared x minus 2p squared equals 25x. I want to bring that x, 25x, to the left-hand side. So I've got minus 25x, which is all equal to, of course, I'm going to take the 2p squared to the right-hand side, which is going to make it positive 2p squared. Let me just write that in a different color so you guys can see what happened, that the symbol actually changed. Then I've got to take x here as a common factor. So I take out x as a common factor. I've got p squared minus 25 equals to 2p squared. And then x is equal to 2p squared over p squared minus 25. So grades-wise, what you're looking at is a merit grade for the final proof. Correct expression without surds gets you an achieved. So I would say this line right here gets you an achieved. So again, if you think about time-wise, I mean, like question 1B took a little bit longer than, I don't know, maybe it took around the same time. But yeah, that's basically question 1C. So with you guys, I know I'm kind of like talking to 2 different people here, but I'm recording and streaming at the same time. So any questions on that one, guys, with question C? Or did I actually just kind of start off straight away and didn't give you guys time to do the work? Yeah, I think that was my bad. Sorry about that. Yeah, Simon, like this question here pops up as an excellence question sometimes when level two, or a merit. Yeah, can come as a merit as well. Um, cool. We ready to go on to the next question? Cool. Yeah, this one I'm going to give you guys some time, all right? Because it's like I actually want you guys to have a go at this. So what is it? It's 8:16, so I'll go through it in about 2.5 minutes for you guys. So we are going at a good pace, guys. We're going to see if we can try and finish this paper by the end of 1 hour. Because I've got another thing that I got to do at 9. But let's see if I can crack this. Senpai, I fully understand what you're trying to say that. Like, that's one of the main reasons I actually focus a lot on merit questions because with merit questions, you can actually get that, yeah, like Kevin is saying, you get an M5 with one question. And if you answer like 3 merit questions in separate versions, you end up with like 15 points, which means you get a merit for the whole paper by answering 3 questions, as opposed to answering, what is it? You would have to answer like, even if you answer 6 achieved questions, you'd only get an achieved, right? Because that gives you 9 points. But if you answer like 3 merit questions, you get a full merit, which like, yeah. So that's what I was saying to you guys earlier about like for achieved, it's really important that like you keep an eye on the clock. And if you find that you're spending more than 5 minutes on an achieved question, just skip it, man. Like go straight to those merit questions. Guys, need a little bit more time, or are you ready for me to go through this question? Yep, yep, yep. Sweet as, sweet as. Give me more time. All right, guys, I'm going to actually go through the answers here. Now, click on record here. Okay, so with this question, it's been coming for the last few years, right? Like pretty much every year, a variation of this question comes. And I know that if you guys have a look at my 2018 and 2019 papers, I would have done it slightly different. And in today's version, I'm gonna do it slightly different. I'm gonna do this entire thing on the graphics calculator with just minimal rearranging. All right. So the first thing to kind of understand here is we've actually got a solution that's already been given to us. So -2 minus I. So in other words, what I could do is I could say, because it's a solution, then negative 2 minus I cubed minus 2 times negative 2 minus I squared plus b times negative 2 minus I minus 30 is equal to 0. Now, looking at this thing here, just realized that it's not actually popping up. Give us a second. Let's try and see if I can refresh it. This happens every now and then, and it's just so frustrating. Sorry, guys. What do I got to do? I got to refresh this to see if it's coming up. Come back. Come on. There we go. Yeah, sorry about that. Just got a little bit delayed there with the... Anyway, so what we know is that because that negative 2 minus I is a solution, I'm literally going to just, put that all in there. And, you could actually work this out. Again, you can do this in the calculator in one shot. And that's what I'm going to show you guys today. So the idea is this, all right? Before I actually put it on the calculator, what I'm going to do here is I'm going to rearrange this. And I just want to rearrange this slightly in a different way so that you guys can actually see what's happening here. So what I'm going to do is I'm going to leave BZ here, and I'm going to take all of the other terms to the other side. So I've got 30 plus 2z squared minus z cubed. Then I can say that b is equal to 30 plus 2z squared minus z cubed divided by z. Right, and the reason why I did this is because, like I said to you guys, I'm going to use the calculator to try and do this in like one shot. So that right there is negative 2 minus I, that's negative 2 minus I, and that's negative 2 minus I. Really good idea is to put a bracket around this. So here comes the magic, all right, to try and do this as fast as possible because you want to save time in your exams and you don't want to be like making silly mistakes with this. So what I would do here is I go minus 2 minus I, and I just put that as equals. So basically what this does is in the calculator, it actually stores as the answer function. All right, so anytime answer is pressed, that's what it's stored as. So the next step is I'm going to go 30 plus 2 times answer squared, because that's what the answer was, negative 2 minus I, then minus answer cubed, because that was z cubed, and then divided by z, which in this case is answer. And if I click on it, I'm going to get b is equal to negative 19. And pretty much that's all that you guys need to kind of show there. So you've shown that you've substituted z to find out what b is. Because like really you don't, like there's so many ways in which you can actually do this question. But yeah, that's pretty much the first part of this question here. So just showing what b is, that b is equal to negative 19. Now the next part of the question is trying to figure out the other two solutions. Our first solution is already given, which is minus 2 minus I. Our second solution is going to be the conjugate of it, so negative 2 plus I. Now we need to figure out what that last value is. And the way we're going to do that is, remember, like if we do Z1, sorry, not Z1, Z minus Z1 times Z minus Z2 times Z minus Z3, it equals to basically this part right here. Z cubed minus 2Z squared. We've figured out what B is, which is minus 19. Z minus 30. But the only thing that we are really interested is the constant, which is minus 30. Because we know that negative Z1 multiplied by negative Z2 multiplied by negative Z3 equals to negative 30. So that's what we're going to do here. So we've got negative Z1, which is minus 2 minus I, multiplied by negative Z2, which is negative 2 plus I, multiplied by negative Z3. Now, we don't know what negative Z3 is, but we don't know what Z3 is, so we're just going to leave it as that is. So next step is we can actually go negative Z3 equals negative 30 divided by negative 2 minus I multiplied by negative 2 plus I. So once again, I'm going to go to the calculator and I'm just going to chuck it on in the calculator and make sure it's not that. So I've got negative 30 divided by, I'm going to open up a bracket, minus, what I've got, negative 2 minus I, negative 2 minus I, and then multiplied by negative 2 plus I. I hope that's all the correct calculation there. And what I've got here is negative Z3 is actually equal to negative 6. So then I can say that Z3 equals to 6. So my all my solutions are negative 2 minus I. Second solution is negative 2 plus I. Third solution is positive 6 right there. So grades wise, what we're looking at is you have to get both negative 19 and the other two solutions. So you have to get this and negative 19 for a merit. But you could get an achieved if you get either negative 19 as B or one of them to get an achieved. Yeah, a bit of a standard question. And I know like I've done this question like lots of different ways in the last few years worth of exam papers. So a lot of different strategies that you guys can try for this type of question. But ultimately, I think what we're looking for in the answer schedule is that the two final answers correctly given. All right, let's have a look. Question. Well, you know, guys, honestly, I look at that part for B, right? Like you've just done I think you show what your understanding is, and you're using it in the calculator. So I think it should be fine. Because I'll show you guys the answer schedule, right? Where is it? Like, see, the first thing that they actually say is like Z minus 2 plus I is a solution, but then we are pretty much doing this step here. So we are showing this step. But what we're doing is we're going from here straight to here. All right, so that's fine. And if you look at the bottom one, they're doing like an expanding version of it. So it's a completely different way that they're doing it. But the way we're kind of working out is using the graphics calculator, which is just using a hack right there and kind of working through that. All right, guys, we're going to go to the last question for 1E. Oh, by the way, any other questions with question 1D? Cool, no questions, we can move on. Whoever that was talking earlier, I think might have been Ivan. If you're still here, Ivan. Is it Ivan? I can't remember now. It is Ivan. So Ivan, we're going to be doing this type of question here. All right, guys. So the clue that I'm going to give you guys here is this, right? This question, if you guys get in the exam paper, like especially with locus questions, you gotta be like a little bit excited. Why? Because the answers are fairly, the working out is fairly straightforward. Your first thing is this. Remember that you put z is equal to x plus iy, and then substitute it in here and here, and basically work out the modulus, which means you're going to end up with a beautiful quadratic equation, and you just got to rearrange it to get to that x plus a squared plus y plus b squared format. All right, so I'm going to give you guys some time to kind of have a play around with it, because like I said to you, even getting to a particular stage in this question could get you an achieved or a merit. All right, so keep that in mind whenever you see these excellence questions, is that working to a particular point in the question is actually worth some sort of marks. So have a go at this, and I'm going to give you guys like a nice bit of time here for you. What do we got? 8:35, 35 seconds. Okay, so maybe I'll go through it at 8:34. I'll check in with you guys 8:34. Otherwise, I'll just start working through it. Now this one is a circle. Cartesian, it just means it's a Cartesian plane. So it's like X and Y plane. And also, guys, remember this. Just a quick little tip for you guys for this question. Modulus of this is equal to x squared plus y squared. That's a little, very handy little tip for doing locus questions. Beckhamster, I probably need to see the working for it, man. Curious to know how you do it. All right, guys, do you want me to start going through this question or do you guys need a bit more time? Yep. One more minute. Sure. Um, I used to answer your question while these people are working on this one. You break it down like this, right? Like, look, you get 1 hour for complex numbers. You get 3 questions. All right, so that's like 20 minutes for each question. So in this 20 minutes, you've got to do 2 achieveds, 2 merits, and 1 excellence question. My timing, the way I've always suggested people is like, so this is 2 achieved questions. So basically you're spending 1, 1, 4, 4, and 10. Like that's how I would do it. I'm not saying that that's the recommended time for all of you guys. That's how I would do it. Because if I'm finding that I'm spending like more than 1 minute on an achieved question, um, then I'd be like, do I really want to be doing this achieved for 3 points, or do I want to be spending more time on that merit question for 5 points, M5 or an M6? All right, guys, I think that's good enough time there. So Ayush, hopefully that answered that question there, mate. Like, yeah, it's basically breaking your timings down to go, how much time am I going to spend it? Now, let me put another one, right? If I see this excellence question in the paper, I would, and I know, and I'm like, oh, yeah, I know how to do this excellence question. I'm not even, like, I won't even bother doing the achieved and merit questions because I'll be like, yep, I know what I'm doing here. That means I'm going to get an E7 or an E8. And that's really quite crucial to notice with complex numbers questions, because in complex numbers exam, what happens is like a lot of times they ask you guys to do proofs. And you know that with proofs, if you get the final answer, you're going to get the full 8 points, right? So that means you go look at it and go, okay, look, if I get this, if I can do this question in 10 minutes, I'm going to get 8 points and I don't have to worry about the other merit questions or achieved questions. I mean, I'll do it as a backup just in case, but if it's a proof, you know you've got the answer and you've actually proved the answer, which means you're guaranteed to get those 8 points. Okay, Senpai, I'm going to start doing this. I'm just going to go through that starting part of that instructions again, guys, because I've got to record from scratch. But I'm going to go through this fully, and then at the end, I'll ask you guys for any questions. Cool. So with question 1E, anytime you guys see a locus question or a Cartesian plane, is we always remember that z equals to x plus iy. And also remember that the modulus of x plus iy is actually equal to square root of x squared plus y squared. Now this two things is a must know for any type of locus questions, because it's just like, yeah, those are your two key things that's going to help you solve this question. So what am I going to do here? I'm going to replace the z with x plus iy. So I've got x plus iy plus 2 minus 7i is equal to 2 x plus iy minus 10 plus 2i. So this is what I've got so far. My next step is to collect all the real parts and the imaginary parts. So here I'm going to get x plus 2 plus y minus 7i equals 2 times x minus 10 plus y plus 2i. So at this point, I can actually use the modulus equation and get rid of those two lines. And I'm going to replace it with x plus 2 squared plus y minus 7 squared equals 2 times x minus 10 squared plus y plus 2 squared. So far, so good. Next thing, I need to get rid of the square root symbol. So I've got to square everything. And when I square everything on the left-hand side, the square root symbol disappears nicely. So I don't have to worry about it. But on the right-hand side, I've got the 2. So that's going to become 4 multiplied by x minus 10 squared plus y plus 2 squared. Now, here's the thing. We don't have a choice. We've got a ugly as long quadratic equation that we've got to expand, and we've got to rearrange, and we've got to complete the square and somehow bring it to this format right here. All right. Now, remember this. If you can get actually up to here, then there's a very good chance that you're going to get at least a merit, because all you have to do at this point is expand and rearrange, collect all your like terms, and you're pretty much good to go, right? So that's what I got to do here. And bear with me, guys. It's going to take a bit of time. So what do we got? We got x squared plus 4x plus 4 plus y squared minus 14y plus 49 equals 4 times. I'm going to keep all of that inside because then it's just easier for me to expand out. Minus 20x plus 100 plus y squared plus 4y plus 4. And I guess this is the part where I have to actually expand it out. Why do they give us this long questions? And I guess that's why you kind of need like 10 minutes to kind of like go through these questions. So 4x squared minus 80x plus 400 plus 4y squared plus 16y plus 16. And here's a little trick, all right? And this is a bit of a cheap trick, but it does work in this case anyway. So I'm going to make the left-hand side 0 because I want to rearrange everything. And what I'm going to do is kind of write all those terms underneath it because x squared is right here. So that's minus x squared minus 4x minus 4 minus y squared plus 14y and minus 49. I hope I got that right. Yep, let's see how that goes. So now I can actually easily eliminate it because then I can write it as 3x squared minus 84x. I've got plus 400, 396 plus 3y squared plus 30y minus 49. No, not 49. Oops. 16 take away 49. See, this is what happens. Like late into the night, my head just starts. Don't want to make mistakes in this. So minus 33, and I'm just going to do that 396 minus 33 to give me 363. So what I've got here is 0 is equal to 3x squared minus 84x plus 363 plus 3y squared plus 30y. Now looking at all these numbers, I can see that 3 is a common factor. So I'm going to take 3 out. So I've got 84 divided by 3, which is 28. 363 divided by 3 is 121 plus y squared plus 10y. I can get rid of the 3 now because 0 divided by 3 is just 0. So I'm going to get 0 equals x squared minus 28x plus y squared plus 10y plus 121. Now, this is where I need to do complete the square. So what I am going to do is I'm going to rewrite this now, x squared minus 28x plus y squared plus 10y plus 121 equals to 0. I'm going to move that 121 to the other side. Just bear with me, guys. If you have forgotten completing the square, it's not too difficult, all right? Because I'm going to show it to you in like one shot here. So to complete the square, first off, I'm looking at that negative 28. All right, so I'm going to do negative 28 divided by 2. Let's delete all of that. Negative 28 divided by 2 is going to give me that, and I'm going to square that. So negative 14 squared is 196. So all I got to do here is I'm going to add 196 to, let me just put that in a different color. This is how you complete the square. I'm going to add 196 here, and I'm going to add 196 here. Next, I'm going to look at the 10 here, and it's positive 10. So 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25. And on this side, I'm also going to add 25. So with that in mind, here I'm going to get x minus 14 squared plus y plus 5 squared equals 196 plus 25 minus 121 equals 100. And basically, guys, I've actually done that question. Yeah, that's pretty much it. That's how you do the completing the square. And you're done. So grades wise, what are we looking at? Excellence for the final proof part of it. So that's the last bit right there. Now for a merit correct equation for x and y without surds, for merit correct equation for x and y without i's or surds. So you're looking at a merit. Wow. Really? Up to here? I'm looking at the exam schedule. I'll show you guys what I mean by, where is it? Check out this. Correct equation for x and y without i's or surds gets you a merit, which means that's this line right here. That line right there is correct. Yeah, that's got no i's or surds, so that'll be a merit. There you go. And of course, achieved is correctly separating the real and complex components on both sides. So that would mean separating it is about here, is where you're looking at an achieved. So yeah, like I said to you guys, this question here, while it's long, but it's a proof, like it's a question where you know you're going to get an answer, and it's a nice answer, which means, yeah, just got to keep persevering at it, and kind of keep going till you get that answer. But yeah, that's basically it for question 1, guys. Now we go to question 2. All right, let's come back to the stream. I missed a lot of questions there, but like I'm gonna come and ask you guys if there's any questions. Senpai, hopefully it kind of made sense as how to do the completing the square. No worries, Jax. Thanks for the shout out, man. Appreciate it. Yep, K equals 100, guys. Yeah, you got it. You got it. So if they did ask you a follow-up question like where's the center and the radius, then you're going to write the center is at 14, -5 with a radius of 10. Because remember, it's r squared. Yeah, only if they ask you that question. Sometimes they ask you what type of shape is it. Um, then you need to kind of say what the question is. Let me have a look, Zaddy Dynamite. So you needed, for this particular paper, you needed 21 points for an excellence. And because it's 21 points, you would need a E8. Yeah, you need an E8 and an M6 and probably an E7 to get an excellence. But again, this study, it depends on what type of paper. Sometimes they drop it to a 20. If they drop it to a 20, then you get two M6 and an M8. You're done. You get an excellence. All right. So it does happen on the odd occasion. Yeah, I hate. I feel like the 21 points is a bit harsh. Um, I prefer the 20, but it is what it is, right? Cool, Ivan. I think you should be okay with that question from now on. If you guys ever see locust questions, do what I did in that red box first, all right? Chuck that information and just start chipping away at it. Trust me, it will actually come out right at the end. And if it doesn't come out right at the end, it means you've done a silly mistake somewhere. So this is what I was talking about Ayush earlier. You know, you would rather spend 15 minutes on this question to make sure you get an E8. Senpai, in this question, how do you get an E8? Is if you do something like this. What do we do? 121, right? So there you go. You do that. If you do that, you're going to get an E7, Senpai. So it's like a minor error is where you guys get a E7. Check, what do I say? What do I say? Check Instagram, check my website, all the live tutorial schedules up there, Joy, for the next 1 month. I'm not going anywhere. I'm here. It depends, Ayush. Like I said, like if you actually pick up a question which is a proof question, right? I would just go for it because proof questions generally, and if you're confident with the proof question, then you just go for it because it's like you end up nailing that question, which means, and if you're confident that your proof is all correct, then you can pretty much go, yep, I'm all good with this. Get a E8, which means I'm not really stressed about getting those achievements and merits before. I'm not in, man. I'm not in, Zaddy. I'm still at home at the moment, so because I'm at intermediate, so I don't really, yeah, we don't really know anything yet. Cool. We're gonna have a little 5 minute break, guys. I just want to kind of go back and just double check on something else in my calendar. 5 minute break, and then we'll be back to it. All right. Actually, let's not take a five. Let's take a 3 minute break. So we'll come back at 8:54. All right, guys, just another quick question because I know I was hoping to kind of like smash through the paper, but we ended up talking a little bit more. Did you guys want to continue with this second question, or do we want to actually call it right here? Just need to know if you want to keep carrying on or stop here. One more, as in like one more whole question, or all right, all right, all right. We'll continue. We'll continue. Just thought come and ask you guys first before assuming. Question two, question two, question two. Actually, no, question two, I want to do that. There's a couple of shortcuts for this merit question that I want to show you guys. Unless you guys want to do the two excellence questions, because we could always do that. Should we go straight to 2E and 3E? That way, at least, because I mean, they're going to be ending up like really long questions anyway. But then, Ayush, I think you asked me that question of like, when do I know to attempt a question, a straight up excellence question or not? I think in this case, I would say question 3E is one of those types of questions where I'd go, if I look at it, I'll be like, yeah, I'm going to do that. Okay, cool. Let's do the excellence ones then. We'll do the excellence ones and then I'll record the achieved and merit later and then put it all together later on. All right, let me just rename some files and then we should be good to go. Q1A to E. All right, guys, so let's have a crack at this one here. This is one of those questions, as one of the guys asked earlier, like, how would you know if you see an excellence question and you go, yep, this is something that I'm going to go really, going to go for it straight away. One of these questions, I would definitely say, yep, just go for it straight away. Because even if you get like minor error in these types of questions, potentially with your understanding, you could still get an E7. But unfortunately, this question, damn it, they don't do that. So guys, I'm going to give you guys, how much time should I give you for this? I'm going to give you guys 4 to 5 minutes on this, all right? Because we're only doing excellence questions, I'll give you guys a bit more time. So basically around 9 o'clock, I'll go through the answer, guys. And we are going by my clock, which is at the bottom of the screen there. Five k over 1 plus k squared. Hang on, mate. Yeah, man, that's it. Ayush, you're pretty much done. The key part is this. This is the clue for you. You're so close, Ayush. So here's a little hint for you guys. If something is a purely real number, if it's a purely real number, that means the imaginary part has to equal 0. So this is a little clue for you guys. Where did it go? Purely real number means imaginary part equals to 0. And if it's purely imaginary, then the real part equals to 0. So Ayush, you're super, super close. I hope you can finish it. And I'm going to go through the answer now, guys. Just bear with me while I try and talk to those people that are watching the replay of this. Okay, so with question 2e, what we're trying to look for is values of k that makes this purely a real number. Now, as I said before, and I know I'm kind of just repeating myself here, but purely real number means the imaginary part is equal to 0. And likewise, if you have purely imaginary number, then the real part is equal to 0. So all we got to do with this question is we've got to manipulate this equation or this statement and separate the real and imaginary part. That's all we got to do. All right. So pretty much what we've got here is if u equals k plus 4i divided by 1 plus ki, I'm going to rationalize the denominator, which means I'm going to multiply by 1 minus ki and the numerator by 1 minus ki. This is going back to question, I think, what was it, 1a or 1b that we did, rationalizing the denominator. That's all we're doing here, which means now the numerator ends up being a quadratic. So I've got, basically doing the, well, whatever you want to call it, FOIL first, what, it doesn't matter. Just expanding the brackets. I've got k minus k squared I plus 4i minus 4ki squared. And all of that is divided by difference of two squareds. So it's going to be 1 squared, which is just 1, minus k squared I squared. So with that in mind, in my numerator, I've got k, what do we got? Minus, okay, so this part right here, remember that I squared is actually equal to -1. So -1 times -4 is going to be 4k. -1 times -4 is plus 4k. And in here, I've got minus k squared I plus 4i. All of that divided by 1 plus k squared. So far, so good. Now I need to separate into real and imaginary. So my real part is going to be k plus 4k, which is 5k. So that's 5k divided by 1 plus k squared. And my imaginary part is going to be 4 minus k squared I divided by 1 plus k squared. So all I've done is I've just separated the real part and the imaginary part. Now I'm going back to my question. If the number is purely a real number, then the imaginary part is equal to 0. So this entire thing right here is the imaginary part, and that is actually equal to 0. So I've got 4 minus k squared over 1 plus k squared is equal to 0. And I'm just going to write that at the top here. Imaginary is equal to 0. And what I've got, cross multiplying, I'm going to get 4 minus k squared is equal to 0. And then rearrange it, so k squared equals to 4. Therefore, k is equal to, and really important for this part, is that you actually do square root of 4, which is actually going to give you plus or minus 2. And by the way, if you forget the minus, according to the paper, it says correct values of k. So you actually have to give both plus and minus values. It doesn't say anything about E7. So if you don't get that plus or minus, it's a bit harsh, but I think it might be a merit up to this level because they don't actually show, oh no, 1t with minor errors. So yeah, it might be possible that you get an E7 for it if you just put a +2. So both E8, positive 2 is going to get you only an E7, I would say. Correct expression for u with a rational denominator. So that's going to be achieved, which is here. This line here is going to get you guys an achieved. Yeah, so it's one of those excellence questions where you know what you're working towards. And time-wise, you can kind of like see, okay, this is how much time I'm going to spend on it. And, even explaining it, I think it only took me like 5 minutes to do this problem. So if you think about it, if you want to spend like 10 minutes for an excellence question, not bad. You're going to save a bit of time with these types of questions. Moving on. All right, let's come back to you guys. Yeah, I think I want to show you guys last year's paper, right? Like, I'm trying to think. There was something similar in last year's paper, if I remember correctly. Complex numbers. Let's go straight to the excellence ones. Now that was a long one, that one I remember. Like, check out this. This was last year's paper, right? And I know we just did that. Like, we just did a question like that earlier. Um, just substituting z equals x plus iy and then kind of like working it out. Yeah, I think you guys will nail this question now, after looking at that question 1e that we did earlier on. And then finally, question 3e. Here we go. A little bit more work in this one, but pretty much like, yeah, maybe not so much, but like you do get one E question that's like nicely kind of like get through it real quickly. Yeah, any questions on that one, guys? Any issues, problems, or was it fairly straightforward for an E question? So that was question 2E. Let me know if you guys want to move on to question 3E now. Yep, ready? Okay, cool. Let's go question 3E. Yeah, that's pathetic. Like, look how much space I'd actually given for that question and did it in like a few lines. So here's a proof question. Nasty proof question, I have to say. Oh, actually, no, it's not too bad. Actually, I thought it was nasty, but it's not. Because all you guys got to do is just do one side. So again, I'm going to give you guys a good time limit for this one because there's a lot of playing around with it. But like I said, this was like a proof question. So yeah, you already have what Z is. You just got to do the left-hand side. Just work on the left-hand side and then try and get it to the right-hand side. Ayush, I know you just asked that question. Remember that if you have a quadratic, say you got a quadratic like this, right? And you get two solutions. So this is 2, 4. So these are your two solutions, right? Think about it. When you write this in a equation, you would write this as x minus 2 and x minus 4. So when we had those solutions as z1, which was negative 2 minus I, our first factor is going to be z minus z1. So it's kind of like this, if you think about it. So that's a solution that ends up being there. This entire thing is a solution. So it's going to end up here looking like that. Hopefully that made sense, man. Yeah, no worries. Guys, I'm gonna give you guys another 3 to 4 minutes. Like, let's go through at 9:15, right? So give you guys a good bit of time. But like I said, this is a proof question, so you want to spend a good bit of time on it to try and make sure you get the proof, because you know if you get the proof and you get that final answer, bam, 8 points right there. How are we going, guys? Do we need a bit more time? I think in this question, if you got the answer, you got the answer. You don't, you probably don't need to hang around. However, I am going to suggest this though. I'm going to try something different with this question because I've had a look at the answer schedule and I'm like, okay, that's an interesting way of doing it. It's long, but it's an interesting way of doing it. I'm going to see if I can try and do it another way, which is not shown in the answer schedule. Okay, let me share. I don't want to share the screen because it's like the answer schedule just looks friggin' ugly. But I'll show you guys the basic around it, all right? Because it's like in this particular one, like this is probably what you did. Um, yeah, that's all right. We'll go through it, all right? Let's have a look. So you basically had this. You replace all the Z with this, right? And it's going to get complicated very quickly very fast because I can see that squared plus 1 divided by 2 times a plus bi over a minus bi. I mean, like, I'm looking at this, I'm like, oh God, I don't really want to be spending 20 minutes doing this. But here's the thing. I'm going to try and do this a slightly different way. I forgot to record that. Crap, I got to go through that again. It's all right. Sorry, guys, bear with me. I forgot to press record. Cool. So just going back to this question, what we've got here is we've actually got z, which we need to substitute into that z and that z. Basically, you're going to end up with a super, super ugly equation that you have to somehow manipulate. So this is my super ugly equation. Oh, I forgot the 2 times that as well. A plus bi divided by a minus bi. Cool. Somehow, I've got to manipulate this to equal that. All right. Now, look, that given the time, yeah, you probably can spend quite a bit of time kind of like working through it. But like I was mentioning earlier that I'm going to try a slightly different method here. And what I'm going to do is I'm going to try this method here. I'm not going to how do I say this? I'm going to try separating this and see if that's going to make it slightly easier or not. So all I've done there is I've separated the z squared and the 1 into 2 separate fractions, right? Because theoretically, I could cancel out 1z and z, and what I have is z divided by 2 plus 1 over 2 times z. What would happen if I substitute z now? Because I'm going to get a plus bi divided by a minus bi. And remember, z over 2 is the same thing as saying half times z. So I've got a half multiplied by that. Is it going to make any difference is what I'm trying to figure out. Plus 2z, so plus 1 over 2 times z, which is going to be a plus bi divided by a minus bi. And because of this being a fraction, 1 over that, I could literally just flip it over. So it's kind of like this. If I have 1 over 3 over 2, this could be said as 2 over 3. So that's what I'm going to do here. I've got a half multiplied by a plus bi over a minus bi plus a half times a minus bi, because that's now in the numerator, divided by a plus bi. Okay, this seems interesting so far. I'm liking it so far because like it kind of starting to make sense. Now what I got to do is, because I've got 2 halves, I'm going to take the half out as a common factor, and I'm going to bring it back much later. Right now I'm just going to focus on this, which is a plus bi over a minus bi plus, not multiplied, plus a minus bi divided by a plus bi. And I'm leaving this space here for a particular reason, because I am going to multiply by the conjugate of it. So I've got a plus bi and a plus bi, and then multiply it with a minus bi divided by a minus bi. Okay, so far, so good. This is looking promising, actually. In my denominator, because I've got a plus bi squared here, I'm going to expand the brackets. So I'm going to treat this as a quadratic. So multiply that and that, that and that and that and that, whatever that's going to be. So it's going to be a squared plus 2abi plus b squared I squared. And that whole thing, remember, they all have the same common denominator, which is a minus bi multiplied by a plus bi. And the next part, I've got to do these ones. So I've got to go that multiplied by that, that, and that, which is going to give me a squared minus 2abi plus b squared I squared. Now this is looking very promising, actually. So half and I've got a squared plus a squared, which is 2a squared. That's a squared and a squared. Then I've got 2ab and minus 2ab disappears. Then I've got b squared, I squared, b squared, I squared. So that's plus 2b squared, I squared. Divided by, we got a difference of two squares there. So that's just going to be a squared minus b squared, I squared. So far, so good. And I've got a half. I can take the 2 out as a common factor. So I'm going to get half times 2. And in the numerator, I've got a squared plus b squared. And I squared is equal to -1 divided by a squared minus b squared minus 1. Now, 2 times half disappears because it's just 1. And in the numerator, I've got a squared minus b squared divided by a squared plus b squared. Now, this is not the conventional way of actually going about proving this. You know what? I don't know. I just saw this. I thought, you know, why do I have to do the regular method? Why don't I try doing something like this? And guess what? We are still ending up with that same proof there. So grades wise, what we're looking at is correct proof is going to be an excellence question. Sorry, excellence for the correct proof. Merit is, this is where things get tricky because I did an alternate method. There's like 2 methods that they've given in the answer schedule. I'll show you guys. So the first method is that one there, which is, well, it's still ugly. It's long. And yeah, you know, it's just like lots of different ways. Like obviously there's like 3 different ways of doing this. Here's another way they did this. And again, but they all had that same starting point of the left-hand side. They all did what we did right at the start. But I kind of changed it towards the end. So the merit part is where they said is like somewhere here, and achieved was there. Where are we going to go? Main recording again. How did you guys find that one? Like doing it this way? Ayush, the video gets recorded, like it gets uploaded within like a couple of minutes or 2 minutes. The moment the stream's finished, it gets uploaded. Yeah, that's what I felt, Zaddy. Like I felt that this method was just like, I mean, I wanted to separate the Z straight away because I didn't want to deal with the Z squared because Z squared was like, oh God, like there's so much expanding that you got to do with that Z squared. My first instinct was, how could I get rid of the Z squared and just make it a little bit more simpler? Simon, if you have that thought, man, just go for it, all right? Because I mean, as you can see, like, how many lines did we do this in? Like 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Yeah, and I know I kind of like dragged on a bit with some of those ones, but like the moment I separated it, it's like knowing these little tricks, right? So if you think about it, your first trick is this part right here, separating it. That's like trick number 1. I might actually record this. Give me a second. Yeah, so we're just kind of like going through the different variations. So with this one, the first trick was to kind of separate it. So that was trick number 1. Trick number 2 is right here, is understanding that when you actually divide by a fraction, you can rewrite this. Someone asked in the chat there, is half 1 over 2z is, no, it's not the same as 0.5z. Half z, this is equal to 0.5z. All right, the z is actually in the denominator. So in this case, I saw that a plus bi in the denominator, and I knew straight away I could do something like this, which would actually flip it over. Yeah, it's a good point, Simon, because yeah, it's really easy to make mistakes, especially when you're working with Z and 2, that you can actually kind of like mistake your own handwriting for z, for 2 as a, or mistake z as a 2 or a 2 as a z. Even my half times z there is quite not any better right there. There we go. Probably should do that more often. Okay, let me just go back to the answer schedule. Where is it? Sorry, I'm looking at multiple screens. I just need to pull the chat out for a second. How did they go from third to last line to second to last line? Hang on, mate. I'm just rearranging my desktop. So, Senpai, are you talking about the first method? So this is the first method, right? So best to work with like line numbers. So imagine that this is line 1, line 2, line 3, line 4, line 5, line 6, line 7. Which line were you asking for? Would you guys like me to have a go with the first method to kind of explain to you guys? Would that help? Five to six. So that's 1, 2, 3, 4, 5. 5 to 6. 5 to 6. Okay, let me just show you 5 to 6 separately, all right? So 5 was 2. I'm just writing it down, hold on. All right, this is line 5 to line 6 senpai for you. So basically this was line 5, right? So the first thing you got to do is cancel the 2 2's. Once you cancel the 2 2's, you can actually rewrite this as a squared minus b squared over a minus bi squared divided by a plus bi over a minus bi. Then we do the reciprocal of it. So a squared minus b squared over a minus bi squared multiplied by a minus bi, a plus bi. So because we now have a reciprocal of it, this cancels with one of them, and what we left over with is a squared minus b squared divided by a minus bi and a plus bi. Then we can cross multiply, like difference of two squares, which means you're going to get a squared plus b squared. So that's another cool trick to have as well. Like when you have like a fraction divided by a fraction, you multiply it with its reciprocal. Cool. Any other questions, guys? Just having a quick look. Don't worry, Ayush. When you come to the differentiation tutorial, we'll go through a few of those questions, man. Good luck, Zeddy. Keep an eye on those excellence questions, hey? Maybe we can tinker with them once the mocks are over. No problem, Kyle. Good luck, man. Good luck. All right, guys. Nah. I think that's us. We'll call it today. What I might do is I might just record the remaining questions later on in the night, and I will wrap it all up and put it together as one video. But yeah, you can watch the replay of this. Should get uploaded in about a couple of minutes. Cool. That's us. When do I see you guys next? When do I see you next? When do I see you next? I see you guys. I see you on Wednesday for differentiation. There we go, Ayush. I see you on Wednesday for differentiation. Next, complex number stream. Check that schedule, hot sauce. I'm sure it'll be there somewhere. But I mean, like, there's all the other streams are all up on the live tutorials. So if you go on the live tutorial playlist, all my videos from past is all there as well, the revision stuff. Sweet, that's it, guys. Have a good one. Yeah, if you're in Auckland, stay safe. If you're elsewhere, good luck and stay safe as well. I will catch you guys on Wednesday for differentiation, and we'll probably do 2017 differentiation paper on Wednesday. So we'll do like a few achieved questions, and then in the last bit, we'll actually do all the 3 excellence questions. Cool, guys. Have a good one. Catch you later.